Based on the given instruction in Program 1A, we will write a program that will blink an LED on pin N as shown in circuit. The LED should blink 1 time per second, 0.5 second on and 0.5 second off, indefinitely. In this program we will need one LED, one 220 ohms resistor, breadboard and the Arduino itself. In here the LED will blink in pin 3. Now in the syntax we define the LED pin located at pin 3, then in our setup function the pin 3 as an output. Furthermore, the loop function will make the LED blink 1 time per second. While in terms on Program 1B, based on the given instruction, we will write a program to the 3 LEDs shown in Circuit 2. Specifically, turn on LED N for 1 second, with the others off. Then turn on LED N plus 1 for 1 second, with the others off. Then turn on LED N plus 2 for 1 second, with the others off. Repeat this exactly 10 times, 30 seconds total. In this program we will need 3 LED, 3 220 ohms resistor, breadboard and the Arduino itself. Again this program should sequences 3 LEDs connected to pins N, N plus 1, and N plus 2. Each LED is turned on for 1 second sequentially, and this sequence repeats 10 times. Now for the syntax of this program we define the N, which is the starting pin number, then the following LED pin located at pin 3, 4, and 5, then in our setup function we declared the pins as an output. Furthermore, inside the loop function we use a for loop that will loop the sequence of the LEDs 10 times. Then we also use a while loop so that it will stop the loop at exactly 10 times or 30 seconds and turn off the LED connected at pin 5. As you can see, the sequence stopped exactly at 30 seconds. Lastly, for the last program 1C. Based on the given instruction we need to write a program that uses a function blink with the parameters of k and m to make an LED on pin k blink exactly m times, 0.5 second on and 0.5 second off. For example, the command blink with parameter 5 and 7 should make an LED on pin 5 blink 7 times. The program should call blink 3 times from setup to do the following. Make the LED on pin N blink 4 times. Then make the LED on pin N plus 1 blink 6 times. Then make the LED on pin N plus 2 blink 3 times. In this last program we will also need 3 LED, 3 220 ohms resistor, breadboard and the Arduino itself. So, for the syntax first we define the LED pins and the value of N, which is 3. Then inside the setup function we declared the pins as an output and added a command that will call the blink function from the setup function 3 times with its argument containing the appropriate pin and number of times the LED will blink in that pin. Then for the parameters of the blink function we declared k as the pin number and m as the number of times it will blink. Inside this function we use a for loop for the LED indicating on how many times it should blink in that pin.
For this task, we will gonna need an LED. The color depends on your color preferences. But for this task, I will gonna use a red LED. Next is a resistor. A resistor value is 222 ohms. We will connect the resistor in series with the positive leg of the LED. Then, the other leg of the resistor will be connected in pin 8. Pin 8 because based on the instruction, the number of pin that we will connect the resistor will base on the number of our member plus 2. Then, the negative leg of the LED will be connected in the ground. Now that our electronic components are already connected with each other, we will proceed in the coding. Within the program, there are 3 tasks that need to be accomplished. First is to connect the digital pin based on the number of your team and add 2. Second task is to turn on the program forever. The given hit is to put the instruction to control the LED in the loop section of the program. And lastly, LED should be on for 0.75 seconds and off for 0.75 seconds. Keeping the task in mind, we should be able to arrive in this kind of code structure. To check if the program is executing properly, we can simulate it in Tinkercad Simulator. Observing how the LED flashes, we can say it turn on right after the second ends and turn off right after the another seconds end.
Click Create and select Circuits from the options. Drag and drop the Arduino Uno R3 board with a breadboard to the workspace. Connect the negative rail to the ground, GND, and the positive rail to the 5V pin on the Arduino. Place the green, yellow, and red LEDs on the breadboard. Connect a 220 ohm resistor to the cathode. Short a leg of each LED and to the ground rail. Connect the anode, longer leg, of the green LED to pin 1, the anode of the yellow LED to pin 3, and the anode of the red LED to pin 5 on the Arduino. Click the Code button and switch to text mode. We start by defining the pins to which the green, yellow, and red LEDs are connected. Here, the green LED is connected to pin 1, the yellow LED to pin 3, and the red LED to pin 5. We then set the pins for the green, yellow, and red LEDs as output pins using the pin mode function. We will simulate a traffic light, where the green LED is on for 10 seconds, the yellow LED is on for 1 second, and the red LED is on for 8 seconds. The traffic light should operate continuously. We can now start the simulation. It works properly. Here is the schematic view of the circuit.
Open a new sketch in the Arduino IDE. We will use the same circuit and code we used on Tinkercad. Make sure that your Arduino is connected to your computer using a USB cable. From the Select Board button, choose the Arduino that is connected to your computer. Click Verify or the check button to start compiling. This time, we will be testing it on an actual Arduino Uno board. Once done, click the Upload button to upload the program to the Arduino. You should now see the output on the actual board. The simulation of the traffic light circuit works properly, indicating the green, yellow, and red LEDs turn on and off in the correct sequence and timing.